Welcome to the ultimate showdown, quadrilaterals versus rectangles. Actually, I'm just kind of kidding around. They get along just great. There's no fight here. But we are today going to learn about quadrilaterals and rectangles. And if you've never heard this word before, we will define it in just a second. So your learning goal for today is I can identify the properties of a rectangle that make it different from other kinds of quadrilaterals. Okay. Before we begin today's lesson, though, I just want to ask you this deep thought for the day. Is a square a rectangle? I'm going to give you a few seconds to think about that. I want you to lock an answer into your head, and we'll be answering that question just a little later in this lesson, okay? Okay, I have my answer. Hopefully you have yours. Let's move on. And I just wanted to give you two definitions today because chances are you may not have heard this word before. It's a fairly big word. And that's the beauty of getting higher up in the grades here is we're going to start introducing you to some bigger words. So this word here, quadrilateral, I've actually broken it down because it's made up of two root words, two words that came from older languages in English, the predecessors to English called Latin. So in Latin, the word quad actually means four. Okay. And so you may have heard this, like if you go out into the back country and ride a quad, they gave it that name for a reason because a quad has four wheels. All right. So just to give you a little bit of background of this root word here, quad. Lateral also comes from an old Latin root word that means side, and just a few other places that you may. Yeah, you may see this like in rugby. They do what's called a lateral pass. And so you can't actually toss a rugby ball forward. You have to pass it off to your side. So a lateral pass. Another place I've seen this word is you actually have muscles that run down kind of the side of your torso here. And those are called your laterals or your lats for short. Okay. So a quadrilateral then is literally a four-sided object. All right. Now, mathematicians would have a definition for quadrilateral that looks more like this. They would call it a closed two-dimensional shape with four straight sides. Okay, I just wanted to spend a little bit of time on this word here, a closed two-dimensional shape, and you can see off to the side here. Closed means that there are no breaks in the lines. All right, so just for comparison's sake, if I were to grab a little pen here and draw something that kind of resembles a square, but if I didn't quite connect this straight line with this straight line up here, this is not a closed shape. Therefore, it is not a quadrilateral, okay? So that's what it means. It has to be a closed shape. It's got to be two dimensions, and it has to have four straight sides. So underneath the definition here, I've got a bunch of different categories of quadrilaterals. Rectangles, squares over here, rhombus, parallelogram, trapezoid, kites. And maybe another name for kites would be diamond or yeah, no, that's it, kites. Okay. So anyways, so then down below here, we've got the definition for a rectangle. And a rectangle is a special kind of quadrilateral. That means that it still fits all of these characteristics up here. It's a closed shape, it's two-dimensional, and it has four straight sides. But the thing about a rectangle that makes it unique from, say, other types of quadrilaterals is that it has exactly four right angles. And if you remember a couple of weeks ago, I think it was actually the second last day before Easter break, I taught you about right angles or 90-degree angles. And so down below here, we have a rectangle, and it has exactly four right angles in it. And do remember that we would show that they're right angles by putting this little box. Let's kind of making a little square in the corner there. So you can see that in each of the corners, we have one of those 90-degree angle markers. Therefore, this shape is a rectangle. Okay, well, let's go back to that question that I asked right at the beginning of this lesson. Is a square a rectangle? Remember, the definition for a rectangle is that it has four 90-degree angles in it. Now, does a square fit that definition? Yes, it does. So therefore, squares are rectangles, okay? Rectangles also happen to be rectangles, go figure. But squares are also categorized as rectangles because they do fit the criteria there, four 90-degree angles. Just quickly before we wrap up this lesson today, I just wanted to teach you two proper ways to show, two proper notations to show that we're dealing with a rectangle. Maybe the more commonly used one in math is by using these little ticks along the side here. A lot of times rectangles will have two equal sides that are on opposite sides of the rectangle, okay? So you can see that the top side here is the same length as the bottom side. And we would show that they're the same length by putting a little one tick through here and one tick through here. And that tells us that they're equal. Now, the right side here and the left side are also equal in length to each other, but they're a different length than the top and the bottom. So we have to use a different notation to show that it's a different length. And so a lot of times you'll see two ticks are used to show that this is different from the top, but it's the same as the right side here, okay? So that's maybe the more commonly used notation to show a rectangle. And you will also notice it also shows the 90-degree angles in each of the corners, okay? A less commonly used but still acceptable way to show that is by using letters. Because remember, in algebra, letters can represent any number. But up here, our top and our bottom are the same length. So we're going to use the same letter to show that they're the same length. But of course, the top and the bottom are different lengths than the side here. But the sides are the same length, so we use another letter, a different letter from the top and the bottom, but we're going to use a B to show that the left and the right are equal in length, okay? And again, showing here, we've got 90-degree angles in each of the corners. I've officially beat rectangles to death. I don't think there's anything else you need to know about rectangles for grade 5. So this seems like a great time to wrap up my lesson. I don't complete great skill W11 and show me that you know everything you need to know about rectangles, okay? We'll see you back here tomorrow when we talk about perimeter.